Hello, my name's Anthony Bucci, and I'm a first-time facilitator for Complexity Weekend. I'll be facilitating the upcoming November 2021 session. I'm a computer scientist by training, and I'm based in Cambridge, Massachusetts in the United States. I've been involved in complexity science in one way or another since at least 1999, when I started my computer science PhD at Brandeis University. There I was working in the demo lab under Jordan Pollack, who himself has been involved in complexity science for quite some time. I was studying coevolutionary algorithms there. Those are a kind of evolutionary algorithm that fully takes account of the interaction among simulated agents. And in particular, I was interested in questions around how to decide when one simulated agent is better, in scare quotes, than another, when we know for certain we have only limited information about both of them. That's a key question that arises when designing coevolutionary algorithms of the sort I was interested in. But it's also one of the reasons I found it intriguing is that it's kind of a general question that human beings as limited entities face on a daily basis. So I was kind of hoping that, although I was studying a very particular technical case, that this would somehow translate into more interesting knowledge generally. In any case, coevolutionary algorithms are notorious for their complex dynamics that are often very difficult to understand and have all kinds of names like the Red Queen effect or relative overgeneralization or overspecialization and whatnot. And so I took the route of developing a bit of theory and then some new algorithms inspired by the theory that I thought would be easier to understand dynamically while not sacrificing the promise of these algorithms. How far I succeeded in that is for someone else to judge. After I finished at Brandeis in 2007, I worked for about just under 7 years at a small company called Ecosystem Corporation, where my first job title was literally complexity scientist. Ecosystem was founded by Eric Bonobo, who is a fairly well-known fellow of the Santa Fe Institute for Complex Systems in New Mexico. I'd met him in an elevator at the Artificial Life Conference in Boston in 2004, it turns out. So I would say, if you can, try to be nice to people in elevators. In any case, Ecosystem's stated mission was to become a successful business applying complexity science principles to real-world industrial scale problems. Unfortunately, the company went bankrupt a few years after the 2008 crash and the turmoil that followed it. But the company did have a great run, and I had a chance to work on a wide variety of industrial problems and projects, oftentimes building agent-based models or using evolutionary computation methods, including coevolutionary algorithms, on these problems. And I would say in my time there, I worked on or contributed to maybe 20 or 30 agent-based models for things ranging from the yield of soybean crops to why people weren't using certain benefits and insurance policies to U.S. Navy personnel choices, all kinds of things all over the place. And some of them are quite large scale. That Navy project I mentioned, I worked on briefly, but that simulated the entire U.S. Navy, all the people. So that was quite a big one. Since leaving Ecosystem, I've consulted independently. I've advised at several startup companies. I actually co-founded a startup company of my own. I've designed and taught a couple of computer science classes at Tufts University up here in the Boston area, and I still occasionally lecture there. I did some research on computer science education with some colleagues in Florida, and most recently I've landed at the Electric Infrastructure Security Council. It's a nonprofit where I've been for the last year, approximately. My title there is Technical Director for Infrastructure Simulation, and I'm more or less responsible for building and evangelizing a very large-scale multi-sector simulation of the interconnected infrastructure system, quite a complex endeavor on its own. So this is essentially an agent-based model that models the electric power grid, so plants and substations and power transmission lines, natural gas system, including pipelines and compression stations and drilling locations, wastewater treatment plants, healthcare facilities, and I think 6 other types of infrastructure. And very importantly, the interconnectivity among them. So the ones, the power plants that serve some of those other entities, like the gas compression stations, that's accounted for in the model. And what we're looking to see is the kind of complex behavior that emerges in these systems under different kinds of scenarios. So the mission of the EIS Council is to improve the resilience of the world's electric grid, and especially so in the face of very large-scale catastrophes that are known as black sky events. So, these are events that take out a very large section of the electrical grid, like a large region. The event we saw in Texas recently, where a large number of power plants went down because of a cold snap there, came close. Came close to that. wasn't quite there, but that's the scale we're looking at. And unfortunately, and quite frighteningly, here in the United States, if a large enough region of the electric grid were to go offline as a result of a solar flare, human accidents, or malicious acts, it's unclear whether it could be brought back online again in a reasonable amount of time. And what I mean by reasonable here is before mass suffering occurs. So that's the mission of this nonprofit, is to try to improve that situation using policy, using publications, and then using the simulation that I'm working on. And part of the role of this simulation is both for communication and demonstration purposes, but also for training, to train people in what to do in these kind of events, scenario testing, and then we aspire ultimately to create something like a GPS navigation system in your car, something analogous to that, where it's almost a digital twin of the world. It takes real-time data. You're able to simulate scenarios in real time and try to make decisions based on the recommendations coming from the outcome of the simulations. But I think we're years away from something like that, if we ever get there. But anyway, to sum all that up, my complexity journey has taken a fairly specific academic and professional route, with a heavy focus on the computer science and the research and software creation side of things. And I just want to say, obviously that's not the only way to come at the topic. Complexities and complexity science, or complexity writ large, is a very large and complex thing of its own, but that's the path that I took. So, getting to the notion of communicating complexity to others, I like to think of it as sort of like a dimension along which human perceptual ability varies, somewhat analogous to but independent from spatial scale and time scale. And so what I mean by that is, if you think about what we're able to see with our unaided eye, we can see things that are roughly our size, maybe a order of magnitude or so bigger or smaller. But anything that's much larger or much smaller than that, or much farther away than that, is mostly invisible to us, whether because we're so close and it's so big that we can't perceive much of it, or that it's so far away the light it emits or reflects just doesn't reach us. Imagine looking at the sky, aiming your eyes directly at where Pluto would be. You just won't see it. So we need instruments. We need devices like telescopes and microscopes to help us see such things more fully. And then likewise, we can perceive events in time if they occur at roughly the same time scale that we ourselves act, maybe seconds to minutes, and around there, a few orders of magnitude, maybe up and down from there. But events that are too much faster or too much slower than that sort of defy our perception. And we need things like recording devices or other kind of transducers to render those events intelligible to us. So I like to think that similarly with systems, and by system I mean very vaguely, stuff together interacting with each other. There's a range of these systems that we can perceive and understand fairly well, but then there's this notion of complexity, the variation that can occur, and as that increases, we have a harder and harder time understanding what that system is doing, even when it's at a temporal and spatial scale that we can ordinarily perceive very well. I think a really interesting, simple example of this is a water fountain. The water kind of goes in a parabolic arc, but if you watch the very top of that arc closely, you'll see that it kind of wiggles up and down, and that movement is essentially chaotic. It's unpredictable, and it comes from the tiny turbulent flows that appear in any kind of flow of water, accumulating and manifesting in this change in height. So something as simple as a water fountain, if you sit there and stare at it, it's kind of going up and down, and how do you explain that? Other than what I just said about the turbulence, well, what's the explanation of this? Turns out to be quite interesting and complex. In any case, So when it comes to communicating, kind of bringing this back to talking about complexity with others, I really think it's important to recognize that other people may not be seeing what you're seeing. We could both be looking at this fountain and seeing completely different phenomena. And if we're going to communicate about the complexity of it, then we have to reach a kind of mutual understanding of this, which entails, most importantly, listening, right? Talking to the other person and hearing what they're seeing, listening to that and really understanding it, and then trying to meet them where they are if you're attempting to communicate to them, as opposed to hear them. And then I think maybe a little worse than that is that the analogs of devices like telescopes or microscopes, which I would say for us is mainly simulations, data analysis, things of this nature, are just not nearly as widespread or familiar to the average person, and they're a lot more awkward to use. Anyone can peek through a telescope and look at the sky, but how many people can simulate the behavior of a water fountain to try to understand why it wiggles that way? That's a very different activity. And I guess what makes that increasingly or even more challenging is that not everybody is fluent in the kind of skills you would need to even begin creating, let alone interpreting a simulation, which themselves can be complex systems all their own. So why am I excited to be a facilitator? Well, years ago, when I was still working on my PhD, I was involved in a Boston area group called Gray Thumb. And the group was all about artificial life, and the name Gray Thumb was a play on the term green thumb, which is, somebody who's good at growing plants. I guess Gray Thumb would be someone who's good at growing artificial life, so to speak. But anyway, the idea was to get together in a casual environment and throw around ideas. And often this was at a bar, which I think nowadays I might change for accessibility reasons, but in any case, that's what was done then. And it was structured around a lecture. So usually the group would invite a speaker, someone who had something interesting to say. They would give a short talk, and then the real fun happened when they were finished, and then everyone just started talking about what they talked, what they spoke about, and riffing on the ideas and so forth. So that group eventually disbanded. And I attribute that to the fact that two of the main organizers had kids, and they chose to focus on their family, which I think is an excellent choice, but I do miss that group. And so I'm looking forward to engaging again with these ideas that we used to talk about there, and new ideas that pop up with new people and new energy. And especially now, about 15 years have passed since I last went to a Gray Thumb event. So the tools have changed, the idea space has changed, and so much has changed. I'm really looking forward to seeing what transpires. So, as far as the session and mentorship and so on is concerned, in the session I'm facilitating, I'd like to revisit an old favorite topic of mine, which is the hill climber. My PhD advisor once said that you should always use the simplest possible algorithm that gets you the results you want, and only if it doesn't should you add more complexity to the algorithm. And that's a good piece of engineering advice for sure, but I also kind of found it to be a profound piece of advice generally, especially for complexity science, and it's stuck with me ever since. So I figure why not explore that algorithm? And like the hill climber, which by definition seeks to optimize some sort of objective function by wandering through design space and keeping whatever good stuff it finds, I would like the session to be mostly free to roam, but sort of guided by the objective of eventually learning a bit about coevolutionary algorithms. I'm still designing it, so I can't say much more than that, but that's the notion. I'm hoping it'll be free-ranging in a good way and also fun. And it's perfectly fine if it meanders off and we end up talking about simulating kneeling or something like that. But I'm looking to kind of bring out how similar each of these algorithms is in a kind of stepwise fashion, starting from a hill climber and ending with a coevolutionary algorithm. On the surface, they may not seem like they're all that similar, except with a family resemblance, but I think there are some deep connections. And since the coevolutionary algorithm has very complex dynamics and the hill climber doesn't, I think it's an interesting path to explore. And then I guess one thing I bring with me is I've been doing this about 25 years, give or take a few. So, reading fairly deeply about evolutionary algorithms, writing a fair amount about them, um, and a wide variety of problem domains, writing code from scratch many times, both in academic and professional settings. So I bring a lot of experience along. Again, it's of a particular kind, but I'm hoping that whatever's good about that will kind of shine through. So, before I wrap up, I just wanted to thank you for listening. Logistically speaking, I'm going to be on Keybase leading up to Complexity Weekend, and my username is @ABUCCI, so first initial, last name, Bucci. I had a channel created called Explore EvoComp. I've posted a few times in there already, and I'll continue to do so and respond to posts and chat when I can. I'll do my best to pop into some of the pre-weekend events, although I have to say I have a 4-month baby at home, and he takes priority, so that's a little bit tricky time-wise for me, but I'll do my best. And then besides this session, I have, after the session on Saturday, I'll have some office hour time, and then again on Sunday. And I'm totally open to continue working on projects that may come out of this weekend, or mentoring, if that's appropriate, or just keeping in touch and chatting afterwards. So thanks.